Hello, everyone, and welcome to day 3 of the Go journey. Today, we're going to be looking at variables and looping because yesterday we treated values. So today, we're going to treat variables and constants. Yeah, today, we're going to be treating variables, constants, and looping. Something I find strange is actually that Go only has a for loop. There are no while loops in Go. If you don't know what a while loop is, then well, it's a type of loop, and we'll get to see all that. So let's just dive right in. But before we do that, I say we should recap what we learned yesterday. And once again, we're using the Go by Example website, so just check it out. HTTPs gobyexample.com. Yes. So once again, we already know this, and I'm assuming that we all have Go installed on our PCs or whatever you're using. So let's recap what we did yesterday. So yesterday we went into Go's primitive types: strings, integers, floats, booleans, and whatever. So we found that strings can be concatenated, that's adding two strings. Yes, we found that that's possible. Then we found we could do regular math with integers, which are like whole numbers. And we learned that argument passed to functions, if they contain operators like plus or minus, are evaluated before they are passed to their calling functions. And we also learned floats and how to use the division operator. We learned the booleans and the common boolean commands or operators, sorry. Yeah, so that's about all we learned for Go yesterday. And today we're going to be doing variables and looping. Yeah, that's today's interesting topic, I believe. Okay, so let's go back to the browser scene. And let's actually look into variables. Now, for my existing understanding of variables, we can say variables are containers. We could say variables are like containers that hold values. Now, the values they could hold could be things of the primitive types, like strings, integers, floats, boolean. But they can also hold other types that we've not learned yet, at least that we don't know what can go. But yeah, so variables are like containers that hold values. And I think this lesson is going to be about instantiating variables with certain keywords because variables need to be initialized. So yeah, back to the browser. Okay, so in Go, variables are explicitly declared and used by the compiler to e.g. check type correctness of function calls. So it says variables are explicitly declared. Okay. VAR is a keyword that declares one or more variables. For example, here, the variable A points to the string sequence initial or the word initial. And initial is a string because it's surrounded by double quotes. We know this. We learned this yesterday. So you can declare multiple variables at once using VAR. Yeah, that seems to be true. Here, they declare two variables. Then they add some sort of type, which I assume int means the integer types, which are the numbers. So here, they actually tell us what types B and C are. And then we initialize B, C. So B is 1 and C is 2. So Go will infer the type of initialized variables. Okay. Oh, so it means Go does type inferencing, meaning we don't have to tell it that it's an integer. Like here, they didn't say, this is a boolean because it's a true or false value. They didn't say VARD is boolean or VARD then put boolean right here. So here, the Go compiler inferred that this was a boolean. So variables declared without a correct initialization are zero valued. For example, the zero value of an int is 0. Okay, I don't know what zero value means. Usually, if you declare variables without a corresponding initialization, like you don't point them to anything, like how we pointed a to initial. In languages like JavaScript, they become undefined, meaning you didn't define the variable. But here they're saying it's zero value. So I guess we'll find out what that means in a bit. This video is gonna be like 35 minutes long. So once again, I'm going to set a simple counter. I'll probably cut this part out. Timer, not counter. Our 35 minutes counter has begun. So yeah, there's a shorthand syntax for declaring for declaring and initializing a variable, e.g. for var f equals to string is apple in this case. This syntax is okay. We could then do this if we wanted to say f var f is a string that equals to apple. We could use this strange syntax. I've never seen this before. This is a first for me. Okay, but this syntax is only available inside functions. All right, so I can say we could go explore now that we've at least read what we are trying to establish. So let's go back to our browser, our VS Code thing. Sorry. Yes, I'm gonna remove all this because we already understand the premises. No point. Okay, now to build muscle memory, let's define a package. Let's define a package. So that'll be package main. Imports. We're importing the format module fmt. Okay, today I won't use semicolons. And func. I think that's the word func main, because we learned that main is the entry point in Go. Now we want to talk about variables. Let me zoom in a bit more. So yeah, one talk about variables. So we learned how to initialize variables. They said the var keyword is the initialization, then we followed by the variable name. So to initialize a variable, we do var, which is the variable. That's the keyword for initializing variable. Then the name of the variable. The type is going to be a string here. Is it going to be an integer? Is it going to be a float? So basically, the primitives we learned yesterday, what it points to, and what it points to, or what you assign it to. In programming, this is called the assignment operator. That's the equal to sign. It's called the assignment operator. So what you point the assignment operator to should match the type we provide. So say we set this type to string, it means we can't put an int here. If not, there'll be a conflict. So let's initialize a variable name. Let's call it channel name. Okay, let's put a type, and let's say it's of type string. We can set it to watch the code. I think the channel name has space or spaces. So yeah, var channel name watch the code. That's cool. And we can print it fmt dot. Remember that how to print here, we use the print line, so we can print it in a new line. Then we can just write, to my understanding, channel name. So this will just print out the channel name, watch Java code. But if we did something like var name, then we give it this type of string, and we did string is equal, then we put true, which is a boolean. It won't. If we let's try to compile this and see the error it gives us. So first, let's change to the current directory we're in, because we are in the hello directory. So let's go to the hello, and let's do go run. It's the run command for go. So we should have an error. Yes, for line 12, which is the line we're at right now, that says cannot use true on type bool constant as string value in variable declaration. So you say it cannot use true, which is a boolean constant, as string value, because it's not a string. This true is a boolean, so we can't put this in a container that is for strings, because the name is a container for strings. So we can't have a boolean value there. So why would they like true? Yeah, that would work, because true is actually a constant. The only error I have right now is that we declared it and did not use it, which is not really relevant. I believe it's not relevant. I wonder if we'll have a compilation error if we did something like that, because here we only declared the value and didn't use it. So let's see if there will be an error. Oh wow, there is actually an error. The code didn't compile, it didn't print out the channel name as it should have. Or means that when you define a variable in Go, you actually have to use it. I guess there should be a way around that, but we don't know that yet. So yeah. So this is the var keyword for this is the keyword for variable initialization. That's for creating a container. This channel name container is of the type string, meaning it can only hold string values. Now let's try multi-variable declaration. So we can declare multiple variable by syntax. So multi variable declaration. So that would be var man, woman. Okay, I didn't put a type. Let's put the integer type. var man, woman, 9 and 8. So we initialize two variables, both separated by comma, and we give both of them the integer type. Then we initialize the man to 9 and the woman to 8. I wonder if we could put integer in front of both of them, would that be valid syntax? Okay, I guess it's not valid syntax, because it says expected a semicolon, found a comma. So it means even if we are initializing two variables at the same time, we will need one type statement or type hint or whatever it's called. So yeah, we could print this to the console fmt, sorry, fmt.println, printline man, comma, woman. Yeah, let's, well, I guess maybe we're having an error. Let's actually run it and see. Unexpected comma. Oh, the comma is not needed. Yeah, I didn't spell woman correctly. Sorry, my bad. Still, it's like it's still an error. Syntax error. Unexpected woman. Okay, that's funny. So we could just, it means, I guess that bracket is not necessary. Man, woman. Yeah, now this would work. This was my intent originally. I don't even know how the brackets got there. So yeah, Prince watching Jala or watch Jala code, then 9-8. So we just did multi-variable declaration. The variables have to be separated by a comma, but we can only, it's all right if we only give one. In fact, we can only give one type hint or type declaration. Then yeah, we can assign their values doing comma separation. Now, remember the shorthand for variable declaration we saw, which looks like this. Let's try it out. It means when we do this, we don't have to put the var keyword. And also remember that what's it called? Go does type inference. So although I've been putting types like integer and string, it's not absolutely necessary because yeah, they do type inference. So let's see, let's try this new syntax. So let's person, okay, no, should subscribe. Then let's try this fancy syntax and put true. Yeah, it was. So we could do console, not console, sorry, formats the print line should subscribe. So now let's run this and see if you guys should subscribe. Yes, you should in fact subscribe. Wow, I didn't know that. So yeah, everyone please do subscribe. Just follow the code. Yes, thank you. Okay, so we just tried out this fancy syntax, and with this we don't have to use the var keyword, which is nice. Just use this fancy thing and point it to whatever I want to point to. But remember, let's go to the alt tab. Let's go to the browser. Remember how it says something about zero valued. Yes, let's understand what that means. Okay, so variables declared without its corresponding initialization as zero value. For example, the zero value of an int is 0. Okay, I kind of understand what they're saying, but to be specific or to really understand, let's check it out. So they're saying if we declared a variable like character, or say, yeah, variable character, and we didn't do anything with it, we didn't initialize it or anything, we just put the type, okay, and stops. Let's see what's no, I won't put int because it said it will be 0, so string. Let's see what the 0 value of a string is, because variables that are initialized but hold nothing in Go are 0 valued. What is 0 valued? What does this mean? So now let's print this to the console. Print line character. Let's put 0 valued string is equal to, then a comma, character. Remember that the print line function works with a host of stuff separated by commas. Okay, so the 0 value for character is apparently nothing. Probably it's the empty string. In programming, when you don't initialize the string, or you set a string, for example, var bag of type string, to you set this is called an empty string because the string contains nothing. When you print an empty string, it appears like as, I think, nothing or null, depending on the language really. So I guess that's what's happening here as well. The 0 value for a string, an initialized string, but that holds nothing, is probably an empty string. But I'd say let's check what does Go mean when they say 0 value. My bad. Browser soon. And let's see. What does Go to? Consider that. let's see. This search time is all you're after. In Go, the zero value is the default value assigned to variables when they are declared but not explicitly initialized. Okay. This feature ensures that variables have a predictable and safe default state. Okay. I guess it's to avoid things like nulls, preventing uninitialized variables from causing unexpected vehicles. Zero values of different types. Each data type in Go has a corresponding zero value. For integers, as we learned in the Go by example website, the zero value is 0. For floating point numbers, it's 0.0. For booleans, it's false. Okay. So if you initialize a boolean value, and you don't put something in there. So if you initialize a boolean variable and you don't put anything in the variable, it's going to hold a false. Okay. And for strings, is the empty string. Yes, so my guess was accurate. We won't talk about these because we don't know all these types. These aren't primitive types. These are the primitive types, which we've covered. So yeah, these are the zero values for primitives. I guess this kind of brings an end to this module on initializing variables with the var keyword. There's actually another way to initialize variables in Go that I saw on the website, constants, because variables can be changed, at least to the best of my understanding. Most variables can be changed. That's why they can allow you to put nothing in a variable. If you are not allowed to put nothing in a variable, like how we did for this character string, then it would if you are, since you are allowed to put nothing, I think no programming language will want to indefinitely hold a null value, because that could cause problems if the programmer forgets that this value contains null. So that's why it should later be able to be reassigned to something of the type you declared it with. So we should be able to change character to bad, and for this to work. If it didn't work, it would mean that this indefinitely holds a zero value, which doesn't make sense. For constants that cannot be changed, you can't, I believe you shouldn't be able to initialize them without anything, because that would just leave a reference to nothing, which could cause errors later in your code. So yeah, these variables declared with var, okay, variables declared with the var keyword are reassigned. Command, they can be changed. Okay, now yeah, let's go to the next topic, because we've got like 18 minutes left on video, which sounds like a lot, but it's not really a lot. Okay, so let's go back. How's this swing? Yes. So yeah, the next thing we have is constants. Now these are the ones I talked about that cannot be reassigned. So let's look at it. Go supports constants of character, string, boolean, and numeric values. Okay, I think this supports constants for their primitive types, which are character, string, boolean, and numeric values. Okay. Const declares a constant value. Yes. So to declare a constant value, you use the keyword const. Previously, we were using var, but var declares non-constant values that can be reassigned. So here they do const s string. So this is basically saying define a constant variable, meaning a container that cannot hold anything else apart from what you put in the container initially. So constant s string is constant. Yes, a constant statement can appear anywhere a var statement can, because they are both variables. Constant expressions perform arithmetic with arbitrary precision. A numeric constant has no type until it is given one, such as by an explicit conversion. A number can be given a type by using it in a context that requires one, such as a variable assignment or function call. For example, here math.sign expects a float 64. Okay, so would n then be changed into a float 64? Okay, yeah, because they said a number can be given a type by using it in a context that requires one. So n would be changed into a 64-bit float here. And I guess at some point we'll have to look into the type of numbers and probably another video, because right now we're looking at constants. Okay, so once again, constants, the keyword const declares a constant value. Constant values, to my understanding, cannot be changed, but we've not tested that out in Go. So this, because even is from the name constant, you can't change a constant. Constants don't change. So function is the main function. It prints the constant string. Okay, this constant n is initialized to a very big number. and we divide 3e to the 20th. That's 3 exponential 20 by n. Then we format it and print it. We convert it to an integer 64 and print. Then here it's implicitly converted into a float 64. So let's look at constants because our time is past nth octal. Okay, constant. Let's go. So constants. Yes. Constants. We know that constants are declared with the const keyword. They can appear anywhere that we can put VARs or variables. Okay, so let's try it out. Const phone number. Okay, we'll put an let's make this a string. Give it a type and 888999000. Yes, const phone number string. So it's basically like how we did it before. We did const followed by the variable name, followed by the type. But remember, types can be left out because the computer or the compiler will infer then value. Yes. So const phone number string is equal to 888999000. Okay, no problem. Now we can use the format macro to print it to the console. Print line phone number. There's not much to talk about regarding constants. Let's see if constants can be reassigned, but they shouldn't be able to because of their constants. Phone number equals, let's see. Yes, cannot assign to phone number, neither addressable nor a map index expression. You cannot assign to phone number because it is a constant. I don't know what this error message means. But basically, it's saying that this is a constant. You cannot assign to constants, or you cannot reassign to constants rather, because they are constants. You've already got what they are assigned to. Yes. So I guess that's that for this one. Now let's see if we can use I don't think we can use the shorthand for constants. The shorthand I'm talking about is this. I believe we can't use them because then constants have to be declared with the const keyword, unlike var. So let's assume we try something like const mean person. Yes. No, it's not even possible. There's a clear syntax error. So indeed, you can't use this fancy thing with constants. You have to initialize constants the regular way. Now let's see if we can go by without initializing constants. That should also not be possible. Okay, no, my bad. Yeah, missing init expression for main person. So you cannot reassign. Sorry, you cannot define an empty empty constants. Constants do not have 0 values because constants are not meant to be reassigned. The 0 value thing would not work for something like a constant because that would create variables that hold null values in your code, or rather in this case 0 values. You don't want that as a developer because it will cause problems for you if you forget that, oh, this holds a 0 value. So yeah, you can't do this. So basically, constants are just for defining constant variables you do not want to change. They are basically the same thing as var, except var can be changed and constants cannot, which rounds up constants for us because there's not much to speak about. We've not gotten to the fun parts of Go. Probably by like day 5, maybe we could be there, depending on how fast we're going. Now let's go back to our next thing, which is for. Okay, the for loop. So for is Go's only looping construct. I find this odd. Okay, that for is Go's only looping construct, because most languages have a lot of looping constructs. When we refer to looping, we are saying we're going to do X thing over and over again. You just keep doing something until maybe you want to stop. Yeah. Ooh, but Go only has one type. I know in JavaScript we have for loops, we have while loops, we have do while loops. I think it's the same for C. So if we look here, Once again, they initialize the main package, import the format function. They use the variable shorthand to define a variable, an integer variable I. Now, while I, okay, I can't say while, but for I less than 3, we print the value of I. Then, because we don't want this to go indefinitely, go on indefinitely, we increment the value of I, which is standard for making these things. So the most basic type with a single condition. So this is the most basic type of for loop with a single condition. Basically, it's saying a loop as long as I is less than or equal to 3. Once I becomes 4, you stop looping. Yes. So a classic initial condition after for loop. Okay. Here we instantiate j to 0. Then we use a semicolon to separate it from another statement. While j is less than 3, increment j. This j++ is just a fancy way of doing j plus or equals to 1. Like how they did I is equals to I plus 1. J++ is j is equals to j plus 1. The plus plus is an operator called increment. It increments something by 1. And that something has to be a number, of course. It increments a number by 1. Here, we are doing in-loop declaration of a variable. This is standard for languages like JavaScript. But if this is your first language, what they did is basically they are doing the same thing they did here, but they just did it here. Then while j is less than 3, displays the path that displays. Then increment j, displays the path that displays. Then print out stuff. Oh, they also have a range keyword. Wow. Another way of accomplishing the basic do this n times iteration is range over an integer. Okay, so for I actually don't understand this syntax. For I, range 3. Okay, it means we need to understand what range does. If my understanding is correct, this would probably lead us to another data structure. But let's see. Let's see what's range. Go range keyword. What does it do? Go range keyword. Understanding the range keyword in Go. The range keyword in Go is used with the for loop to iterate over elements of various data structures. Yes, so I was expecting this to take us to data structures. And data structures are just ways of storing data. An array is just like a list of data. Slices are basically pieces of arrays. Strings, already know strings. Maps, we haven't talked about maps yet. But if you're familiar with other, maybe JavaScript, they're like JavaScript objects, object literals, or Python dictionaries. And channels, this has to do with them, to my understanding, if I use what I know in Rust. Channels are like for concurrency. So it simplifies the process of accessing elements and their indices or keys and values. So iterating over arrays and slices. When using range with arrays or slices, it returns 2 values, the index and a copy of the element at that index. Okay. So when using range with arrays or slices, yes, it returns 2 values. So basically, range. Okay, so what does range do? Because in this, it says for I equal to range 3. Prints range I. Okay, the best way to understand what something does is to run the code. We've only got 5 minutes left, but probably we'll have to extend this to actually understand what's going here. Okay, yes. So I'm going to copy all, I'll just copy what we need. Then we'll go through it by commenting it in the code. Okay, let's go call app. Okay, let's see. Loops. Yes, I have to remove things like this that got in by accident. Sorry, better leave it. Okay, so this is the basic type of loop. So here we initialize a variable I and set it to 1, which means I is a variable that holds something of the integer type. Now we can think of this as saying that is a condition that as long as this condition holds true, we do what is in this code block. When something is enclosed in this and this, these curly braces, we call that a code block in programming. So for I less than or equals to 3, this can be read as while I is less than or equals to 3, you do this. we print the current value of I. So at first, this will print in the first run of the block, it will print 1. Then on the second run, it will print, okay, no, on the, when it comes to this side, it will increment I by 1. So I is I plus 1. If the current value of I is 1, we do 1 plus 1. So now I has become 2. So now I is equal to 2. So then we come back because we check again. Now I is 2. Is 2 less than or equal to 3? Yes. So we print the current value of I, which is 2. So then that's 2. So 2 is equal to 2 plus 1. So now I is equal to 3. Then we go back to the top of this code. For I less than or equal to 3. Is 3 equal to 3? Yes. Is 3 less than or equal to 3? Yes. So we print the value of I, which is 3. So now we have 3. Then once again, we do 3 is equal to 3 plus 1, which is 4. So I is equal to 4. Then we come and check. Is 4 less than or equal to 3? Yes, it's no, it's not. So we stop. This is the condition for looping. Once this condition is no longer met, we stop and exit the loop. Okay. Now this one, this basically does what we do above, but we use a different variable j and set j to 0. So we initialize j as 0, and while j is less than 3, increment j and print the value of k. So yes, I think we should run this. Let's run this. Let's run the 2 we kind of understand and forget the rest for now. Okay, so go run. Sorry, go run. This is the last thing that got printed, the phone number. So this prints 1, 2, 3 as we inferred, and indeed this prints 0, 1, 2. Now let me explain this. So we initialize j to 0. Okay, let's write it out. Initialize j to 0, comma. Now while j, which is 0, which is at this point 0, is less than 3, then this, you don't immediately do this. You come into this place. So while j is less than 3, print the value of j. So the first value of j that gets printed is 0. Then we come and do this, incrementing j. So j now becomes j is equal to j plus 1. This was used in place of this. If we let this code here, remove this one, the function, depending on how Go works, this would work because it's the same as what we are doing up here. We are just incrementing. The plus plus is the increment operator. So we're incrementing j by 1. So now, at the end of this code run, j would now be 1. Then we would go again. Is j less than 3? Yes. So we print the current value of j, which in this case is 1. Then we do j is equal to j plus 1. 1 plus 1 is 2. Okay, so the timer for the video to be over just came in, but we'll dismiss it till we're done with for loops. J is equal to j plus 1, which is 2. Then we go back to the top. Is 2 less than 3? Yes. So we print 2. 0, 1, 2. Then we come here again. J is equal to j plus 1. Now j is 2. 2 plus 1 is 3. So we come to the top. J is 3 less than 3? No. So we stop. So this condition in the middle is the break point of the loop. We loop as long as this is true. This is the initialization. This is only done in the beginning of the loop. That's why here it's put on the top. Once we've initialized the variable, we don't do it over and over again with the rest of the loop. Then this is done at the end of what we've done in the code block. That's why when we've printed, this is the very last thing we do. So this is done when we've done this. That's when we activate this. So after the first run, where the variable is initialized, we only check this condition and increment. We don't use this again. All right. So yes. Then I would say we should finish this today. All the ways you could use print. Now let's learn how the range something actually works. Okay, one way to do this would be, say, let's do something like this. Let's initialize with the shorthand range 3. Does this not work as, oh wow, it's like this doesn't work as how I expected it to work. Is the range not a function? Or is range a special syntax? Oh my god. Let me add like 10 minutes to the timer. And then after that 10 minutes, if I'm not done, I will just stop the video. Okay. Sorry, 10 minutes. Okay, just added 10 minutes to the timer. Now let's understand what range does. Okay. Let's go to the browser and go back here, go range keyword. Explain for file range 3. Or no, that's fine, breaks 3. Dot, dot, dot. Okay, let's see. No, they brought Python in Go. Let's be specific. Oh. Yes. Let's check Stack Overflow. I've got 8 minutes to figure this out, then we end the video. Okay, package main, import format. For I, then this strange syntax. Format of print line 10 minus I. Okay. Okay, look at someone's explanation. This was explained in 2024. According to the spec, the only syntax allowed is this. Okay. N is a possibly untyped integer. It iterates from 0 to n minus 1. N is exclusive. Okay. So this iterates or this repeats. So this makes the loop repeat from 0 to n minus 1. So let's say n was 5. It will make the loop repeats or counts 0, 1, 2, 3, 4. Then it would stop. If n is less than or equal to 0, the loop iterates nothing here, which makes sense. So because we cannot loop for 0. So for I, then this strange range syntax would print 0, 1, 2, 3, 4. Okay. If we did for I in range 0, it would print nothing because 0, the range goes from 0 to n. If n is 0, 0 to 0, you don't get space to do anything. Minus 1 doesn't get executed. So n has to be positive. Okay, I think I kind of understand now. Wait. Okay, so let's remove this. What this would do for I in range 3 is would print, 3 is n here. So here, n is equal to 3. So this would print from, or this would iterate from 0 to n minus 1. So this would iterate from 0 to, so right here we expect it to print out 0, that's cool. 0, 1, and 2. Because it iterates from 0 to n. It means this would repeat everything in this loop from 0 to 3 minus 1, which is 2. So it will repeat everything here 3 times. And the value of I would change each time. So the first time it would be 0, the second time it would be 1, and the third time it will be 2. Okay, understandable. Now let's try it out. Let's remove these. We'll just comment these ones out. Okay, and I'm having a lot of fun doing this actually. Okay, so go run. Yes, the first range is 0, the second one is 1, and the last one is 2. Fantastic. At least we understand this. This just says repeat. Basically, you can interpret this as repeat what is in the code block n minus 1 times here where n is 3. So repeat. Okay, this repeats what's in the code block for n minus 1 times here n is equal to 3, but it also sets the value of I, to the current value of n minus, the current value or the current range it is in the loop. I believe you guys kind of understand what I'm saying. It's to set I to, first it sets I to 0, then it sets I to 1, then it sets I to 2. So I believe you guys kind of understand what I'm saying, which I expect. So now this is very easy, this one. Because this loop has no condition, it only breaks when it encounters the break keyword. That's what this just means. So if we remove the break keyword, we would have what is called an infinite loop. And you don't want infinite loops because depending on your PC spec, it can crash a PC. We can try it out too. I don't think mine will crash. At least I hope it won't crash. Go run. Let's see. Yep, just keeps going. You don't know how many times it has written loop. And to exit this, you just do Ctrl+C in your terminal. It's not that serious. Yes. So there's that. But if you use the break keyword, it just breaks out of the loop. What these conditions, like the ones here, do is to act as a break when the condition is no longer being met. So it automatically breaks out of the loop for you. But because here we have no condition, we just use the break keyword. So if we use the break, if we run it again now, it only prints the loop once, then it immediately encounter the break keyword. See, it only prints loop one time. Then this is also simple, not really difficult now that we understand what's happening. So here we repeat what's in the code block at 2 minutes for n minus 1 times. So that would be 5 times. And assign n the value every time. So n would be from n would be at first 0, then 1, then 2, then 3, then 4, then 5. Yes. So, and this is the modulo operator. It checks, it basically does remainder division. It checks if this thing is and so if where we currently are the number n currently equals to, if it's an even number, we print continue. We've not looked at if statements, but this is basically English or math if you think about it. So if n modulus 2 is equal to 0, so if n divided by 2 is 0, meaning if n is an even number, we continue. The continue keyword goes back to the top of the loop, back to the top of the loop. It doesn't reach this statement. It will only reach this statement if we encountered an odd number. Then we'd print the odd number. So if we run this code, we will see the odd number being printed, or the odd numbers between 0 and 6 minus 1. So the odd numbers between 0 and 5 will be printed out. So let's run it. Yep, the odd numbers between 0 and 5 were printed out. The odd numbers being 1, 3, and 5. And yeah, 0 is considered an even number. Okay. Oh, that's a wrap. My god. This video is going to be 40 minutes long or thereabouts. We've been recording for like 52 minutes. All right, but yeah, so this brings today's video to an end. If you enjoyed it, please give a like and subscribe. Go seems like a fun language. It has some fun syntax, so I really enjoy doing this. And yeah, if you want to see me keep doing this, just like and subscribe so my videos pop up in your recommendations or whatever. And with time I will improve. So have a nice day. See you later, and thank you for your time.